Hi, Physics 1, Mr. Janowski here. This is Chapter 6 and 7, Homework 4, Problem 3. So this is going to be a two-dimensional force problem with friction and an ugly vector. So, yeah, buckle up. This might be tricky. So let's see what we've got. Charlie and Denise move a 158-kilogram couch across the floor. Charlie pushes directly horizontally with a force of 200 newtons. Denise helps by pulling with a 200-newton force at an angle of 40 degrees above the horizontal. Uh-oh, her force is at an angle. We don't like that. Mu sub k, the coefficient of kinetic friction, between the couch and the floor is 0.200. So let's do step, Oop, where's my thing? There's my thing. Okay. Step, Part A, what are we looking for? What is the normal force on the couch? So F sub n is equal to question mark newtons. In part B, what is the acceleration of the couch? All right, we want acceleration. So A is equal to question mark, and its units will be meters per second squared. On to step 1. Step 1 is the sketch. So what's going on here? We've got a floor. We've got a couch. Technically, this is a love seat because I'm only drawing 2 cushions. A love seat is a type of couch. Okay. So there's our couch. The couch has a mass of 158 kilograms. Charlie is pushing horizontally with a force of 200 newtons. So it doesn't say which way, but I'm going to guess Charlie's pushing to the right. So we have F sub c, force of Charlie, 200 newtons. Denise helps by pulling with a 200 Newton force at an angle of 40 degrees above the horizontal. So she's helping by pulling, so she must be pulling to the right. So I'm going to draw this. Let's assume we have some kind of string or something here. And then Denise is pulling on this. So here's Denise pulling on this. This angle here, this is 40 degrees. And we have force of Denise is also 200 newtons. The other thing we know is mu sub k between the couch and the floor is this number. All right, so I'll write that right here. Mu sub k is 0.200. So that's our sketch. On to step 2, which is free body diagram. So let's look at what's going on here. The couch is now a box. To this box, we will attach only forces. So what forces are acting on this couch? We can assume we're near the surface of the Earth. So we're going to have gravity going down, F sub g. There's going to be a normal force because the couch is touching the ground. So there must be a normal force between the ground and the couch. Charlie is pushing to the right. So force of Charlie is going like that. Denise is pulling at an angle. All right, this is where it's going to get tricky. So how is she pulling? Is she pulling to the right or to the up? Neither. She's pulling at an angle. Silly Denise. So force of Denise is going this way. Here is our angle of 40 degrees. All right, and the whole thing is moving to the right. You know what? I forgot speed lines. Shame on me. The whole thing is moving to the right. So there's your speed lines, indicating that we're moving to the right. If it's moving to the right and we have this coefficient of friction, well, this must not be a frictionless floor. So the force of friction must be going back to the left because we're moving to the right and friction opposes the motion. All right, so we have this. This is true. However, we've got a bit of a problem. One of our vectors is an ugly vector. So right away, you should be looking at this and saying, oh, force of Denise, I don't like you. You're an ugly vector. You're going up and to the right at the same time. So we know what to do with ugly vectors. To ugly vectors, we do step zeros. I'm going to try to put it in up here. So here's our step 0. We have force of Denise. And this angle here is 40 degrees, which is less than 45. So I drew it as less than 45. Force of Denise is 200 newtons. So it's going up and to the right. I need to figure out how much is it going to the right. I will call that F sub dx. Seems like a good name for it. And how much is it going up? and I will call that f sub dy. So that's what I want to figure out. So remember how to do this stuff. So when you're doing trig, I'll do this a little deliberately. F sub d. All right, so we've got a right triangle here. So there's my right angle. F sub d is clearly the hypotenuse. So that side is h. F sub dx. Okay, this is the side that is next to the angle or adjacent to the angle. So this side is, I tried an A and I wrote an O. This side is A for adjacent. And F sub dy, this is the side that is opposite. So this side is O. All right, now remember your trig. SOHCAHTOA. So, ka, and toa. All right, so let's get f sub dx first. So I want a, I know h, I know theta. Which trig thing does a, h, and theta? That would be ka. All right, so therefore, if you're rusty with this stuff, start right here. Start with the definition of cosine. Cosine of theta is equal to a over h. All right, well, in this case, a is really f sub dx, and h is really f sub d. Okay, I'm going to lose this middle part here. I don't need that anymore because I have this. I'm trying to solve for f sub dx. So what this is going to give me is f sub dx is equal to f sub d times cosine of theta. Okay? F sub d is really equal to 200 newtons times cosine of 40.0 degrees. And we're going to end up with f sub dx is equal to, let me ask calculator, 200 times cosine 40. We get 153.20888. All right. So 153.2 newtons. So I have that component. So let me go back to green real quick to write that one in. All right, so that is 153.2 newtons. Now we need f sub dy. All right, so I'll skip a little bit of the steps here. Kind of similar to this line here. I'm going to skip ahead and say that I know that f sub dy must be equal to f sub d times sine of theta. Because I want O, I know H, I know theta. I'm using so. Convince yourself that this is true. So put in the numbers, f sub d, 200 newtons, times sine of 40.0 degrees, and you will end up with f sub dy is equal to 200 times sine of 40, 128.557. Let's round that off to 128.6 newtons. So I'm keeping 4 sig figs at this point. It's not a bad idea to keep, an extra digit or two in the middle of these problems so that you're not rounding and then rounding again and again and again. So yeah. So we've done all that. I now have my two pretty components. Where do I go from here? I'm actually going to go back and I'm going to redo my step 2. Only this time I'm going to draw one that only has pretty components. So let's start with the box. And the pretty components we had before were f sub g, f sub n, f sub c, don't forget about Charlie, and f sub k. But instead of drawing this ugly vector again, the whole point of doing that step 0 was to get two pretty components, this guy and this guy. So now I know that f sub d x is going to the right. That is an x. And f sub dy is going up. So now I have a step 2 that only has pretty components, which is good because I can work with that. So on to step 3. What color for step 3? I'll go green. So just like the other problems, the other two-dimensional force problems, start with the y side. So, yeah, it's F equals ma, but it's really sigma F with a hat equals ma with a hat, and it's really sigma F sub y is equal to ma sub y. All right, now let's look at this. A sub y. How much is this couch accelerating in the y direction? Is it accelerating upwards or downwards? No, it's doing neither of those things. So a sub y is 0, which means the whole right side of this is going to be 0, because m times 0 will give you 0. Sigma F sub y, sum of the forces in the y direction. So go back, grab all of your forces in the y direction, ignore the ones in the x direction because those are independent of the ones in the y direction. So we're grabbing just these guys, we're putting hats on all of them, and we're plussing them together. So that'll give me F sub n with a hat plus F sub dy with a hat plus F sub g with a hat. So at this point, in step 3, I'm only making a list of my forces, and I know that they have different directions, but I'm not worried about that because I don't want to do too much at once. I just want to make the list of my forces, and I'll remember that they have different directions just by putting hats on them. And I'll worry about the directions when I take off the hats. That's the purpose of the hats. So moving on to step 4 in the y direction. So take off the hats, put in the signs. So F sub n, well, that one's going up. So that gets a plus. F sub dy, that is also going up. So that gets a plus. Plus F sub g. Okay, take the hat off of F sub g. F sub g is going down, so that gets a minus. And all of this is equal to 0. Now, the thing I'm trying to solve for here is F sub n. I want to get this guy by itself on one side. So I'm going to subtract F sub dy from both sides, and I'm going to add F sub g to both sides. And that's going to give me minus F sub dy plus F sub g. So convince yourself that that algebra is correct. F sub dy, well, that's a number I already know. F sub g, well, remember F sub g is equal to mg. So I'm going to rewrite this. It's equal to minus F sub dy. I'm keeping that the way it is for now. But I'm going to replace F sub g with mg. And now I'm going to put in my numbers. So minus F sub dy really means minus 128.6 newtons plus m is 158 kilograms. And g is 9.8 meters per second squared. So if you ask your calculator, what is minus 128.6 plus 158 times 9.8, and then you hit enter, it will tell you 1419.8. So 1419.8, and it's a force, so it's newtons. Do a quick step. I wanted to solve for normal force in newtons. I have normal force in newtons, so that's good. Is 1419.8, is that a reasonable number of newtons for this normal force from the floor on the couch? It is. So you give it a check. On to step 3 on the x side. So step 3b. Maybe it would make more sense if I had called this step 3y and this step 3x, but whatever. Step 3b, whatever. Well, that's going to be F equals ma, but really it's going to be sigma F sub x with a hat is equal to ma sub x with a hat. All right, now let's look at a sub x. Is it 0? Actually, it could be. We don't know. It could be 0. It could be a positive number. It could be a negative number. It could be that, Charlie and Denise are trying to get this thing going to the right, and it's moving to the right, but friction is winning, so it's slowing down. But yeah, we don't know. Basically, at this point, we can't say that it's 0, so we've got to keep it, which means the right side of this, for now, is going to stay ma sub x with a hat. All right, now the left side of this, sigma f sub x. So grab all of your x forces, f sub k, f sub dx, and f sub c, put hats on them, f sub k with a hat, plus f sub dx with a hat, plus f sub c with a hat. Don't forget Charlie's helping in this problem. So yeah, sigma f sub x becomes those three things with hats all plus together. On to step 4 on this side. And I'm going to try to make this all fit in one place. So step 4, take off the hats, put in the signs. F sub k, well, that one's going left. So that gets a minus. So minus f sub k plus f sub dx. That one's going to the right, so that gets a plus. And then f sub c is also going to the right, so when I take the hat off of that one, it goes to the right. So f sub c, and this is equal to m a sub x. All right, now technically I'm taking the hat off of a sub x, and I've got to guess which way it's going. I'm going to guess it's going to the right, that this thing is actually accelerating to the right, so that one stays positive. I actually recommend you always guess that it's accelerating to the right. The math can get a little weird if you guess the other way, but that's what I'm doing here. All right, so I've got this expression. Which thing am I trying to solve for? I'm trying to solve for a sub x. Okay, so I'm going to divide both sides by m. The reason I do that is to get rid of the m on the right side. So now I have a sub x by itself. And what is this going to be equal to? Let me rewrite it. I'll rewrite it here. Oh, you know what? I'm going to run out of room. Okay. I really want to get this all in one thing. So this is going to be equal to minus f sub k. But I need... Like f sub k is a number I don't know, but I do have this formula that can give me f sub k in terms of mu sub k and f sub n. So instead of writing minus f sub k, I'm going to write minus mu sub k times f sub n. Hopefully that's making sense. Plus f sub dx, that's a number I already know, so I'm fine with leaving it like that for now. Plus f sub dx, plus f sub c. Again, I know that number. And all of this is divided by m. And all of this is equal to a. You know what, to make that a little bit clearer. Oop. There we go. A sub x is going to be equal to this mess. All right, so now we've got to put in the numbers. And that's going to give us, hopefully I can fit this all in. A sub x is equal to minus mu sub k is 0.200. So decimal point right there. Times f sub n. Okay, well, that's this number, 1419.8. Newtons plus f sub dx. Okay, well, that is this number, 153.2. You know, kind of lost the decimal point there, but there is one there. So plus 153.2 newtons, plus f sub c, which all the way back from the beginning, f sub c is 200 newtons. And then this whole thing is going to get divided by the mass of the couch, which is 158 kilograms. All right, so make sure you do this order of operations right. Make sure you're getting the whole numerator and then dividing the whole numerator by the denominator. So one way to do that is to put a big set of parentheses around this. You can do it that way. It's not actually the way that I would do it. So I'll tell you the way I would do it is I would hit minus 0.200 times 1419.8 plus 153.2 plus 200, and then I hit enter, which means on the top I end up with 69.24, and then that gets divided by 158. And if I do all of that, I end up with 0.438, and it's in A, so it's going to have units of meters per second squared, and this is equal to A sub x. So I put a box around it. I think I might be done. Quickly grab your red pen and do a step. So I was looking for A. Well, technically it was A sub x. I wanted it to have units of meters per second squared. So I ended up with A sub x with units of meters per second squared. Now, is this a reasonable number? It's a fairly small number, 0.438 meters per second squared. It's not accelerating very quickly, but when people move a couch, it doesn't accelerate very quickly. So it makes sense that this is a small number, which means I'm happy with this. So I'm giving it a check. So yeah, if you just step back and look at this whole Jamboard here, there's a lot going on. There's lots of little steps. At a glance, you might look at this and say, this is too much work. I can't possibly do this. But hopefully, if you followed it step by step, which in teacher college we call this chunking, break it down into little steps, you could follow the logic of each step and how each step leads into the next step. And by doing it that way, by breaking the big problem down into little tiny steps that you can handle one at a time, yeah, ultimately you get the right answer. So hopefully you found that helpful.